Hello guys, welcome back to Makaut Smashers. In this video, we will explore the second chapter of the data warehouse and data mining, classification and the prediction in the data warehouse and data mining. Classification helps to categorize the data into the predefined labels, means yes, no, or in this order, okay, making it crucial for decision making in the various industries. In another side, prediction, on the other hand, helps to forecast the future values based on existing data patterns. Means someone can ask that what will be the salary of the employee after 2 years, after 3 years, based on the 10 years history of the company and the salary growth pattern. So we will dive into popular classification techniques, including the decision tree, naive Bayes, SBM, support vector machine. Then we will cover the regression methods for prediction and and their evaluation metrics. We will explore the cluster analysis and its role in grouping the data based on similarities. Finally, we will examine the transactional and temporal pattern mining, which uncovers the pattern in the time related and sequential data. By the end of this video, you will understand how these techniques enhance the data analysis. So make sure to like, share and subscribe for more insights, content. And so let's get started. So now the first part, classification, the definition and the use cases. Classification, you can say, it is a supervised learning technique used to categorize the data into the predefined labels. Mean all the information is given to the machines, means the data, their labels, means after all of the columns we see the last column where the labels are given, means yes, no, pass or fails, spam, not spam, etc. So it is widely used in spam detection, fraud analysis, medical diagnosis, image recognition. The process involves training a model on label data, means all the information at the first time in the training process given to the machines, and using it to classify new unseen data. Means after the training process we examine how our algorithm or our machines predict the unseen data sensors. Means classification algorithms analyze the input features and assign a label based on patterns in the training dataset. The two main types of classification are binary classification, means spam or not spam, two types, binary, and multi-class classification, means classifying handwritten digits, weather conditions, good, bad or medium, etc. Classification models can be rule based, probabilistic or machine learning driven. The accuracy of classification depends on data quality, feature selection and algorithmic choice. Model evaluation uses the metrics like the precision, recall and F1 score. Proper training and testing improve the classification performance. So now, decision tree classifier. A decision tree is a hierarchical structure used for classification and decision making. It consists of nodes representing the decisions, branches representing the choices, and leaves representing the outcomes. The algorithm split the data based on feature conditions, forming a tree-like shape structure. Popular algorithms include the ID3, C4.5, CRT. Decision trees are easy to intercept, making them popular in businesses and healthcare. They handle both numerical and categorical data efficiently. However, they can become complex and overfit the large datasets. So pruning techniques mean cutting the tree's portion, helping to prevent the overfitting by removing the unnecessary branches. So decision trees are widely used in loan approval, medical diagnosis and recommendation systems. Their ability to provide clear decision rules makes them valuable for explainable AI. So now, naive Bayes classifier. The naive Bayes is a probabilistic classification algorithm based on Bayes theorem. It assumes that features are independent. No features it is in relation, which simplifies the computations. Means we can work on individual features independently. Despite this assumption, naive Bayes performs well in text classification, spam filtering, sentiment analysis. It calculates the probability of each class given in the input features and selects the most likely class, means the most probable class. The algorithm works well with small datasets and require minimal training data. However, it struggles with highly correlated features. Variants include like the multinomial naive bias, Bernoulli naive bias, Gaussian naive bias. Okay, it is efficient for real-time applications like the email filtering, recommendation system. Due to its speed and simplicity, naive bias remains a fundamental classification technique. So now, support vector machine for classification. SVM is a powerful classification algorithm used for complex datasets. It works by finding the best hyperplane that separates the data points into different classes. Here, hyperplane is a two-dimensional or three-dimensional planes which separates the classes. Okay, this is also a supervised algorithm which have the predefined classes. So based on the data, they can generate the hyperplane. So it can handle both. The SVM use support vectors, the data points that influence the decision boundary. It can handle both linear and non-linear classifications using the kernel function. Here, actually linear and non-linear means what? Because sometimes we cannot classify directly by a straight line that this part is yes and this part is no. Sometimes all mixtures is present in the same area. Means yes no is in the circular fashion. So at that point of time we cannot separate by using a straight line. We need three-dimensional shapes. So we use kernel function, a special type of function. We have polynomial, RBF, radial basis function, and sigmoid. SVM is widely used in image recognition, bioinformatics, and text categorization. It is effective in the high-dimensional spaces, but computationally expensive for large dataset. Proper parameter tuning is essential for achieve the high accuracy. Unlike decision tree, SVM is less interpretable but highly effective for pattern recognition. We will discuss in the pattern recognition subject about SVM. Okay. So now prediction, definition and differences from classification. Prediction is a data mining technique used to estimate the future outcomes based on historical data. Unlike classification, which assigns the labels, prediction, forecast, the numerical values. Okay. For example, classification determines if an email is spam, while prediction estimates the future sales figure. Prediction models rely on statistical and machine learning technique. Common applications include like the stock price forecasting, weather prediction, demand estimation. But regression techniques play a key role in predictive modeling. Model evaluation is also crucial to ensure the accuracy and the reliability. Prediction helps the organizations to make the data-driven decisions and optimize their strategies. Combining prediction and classification improves the decision support system. So now, linear and non-linear regression. Regression is a predictive modeling techniques used to analyze the relationship between the variables. Linear regression assumes a straight line relationship between the input and the output variables. It is represented as the straight lines equations you can see in the screen. Okay. So it is widely used in the economic forecasting and trend analysis. Nonlinear regression captures the complex relationship that cannot be represented by a straight line. Examples include, you can say, polynomial regression, exponential regression, the logistic regression. So there are multiple types of regression. Okay. Regression models helps to identify the key factors influencing the predictions. Also, regularization techniques like the lasso and ridge regression prevent the overfitting. Regression analysis is essential for data-driven decision making. Here, the overfitting means the models have the limitation or to learn from the data, because we have two phases. After means first is training and then the examinations. So in the training process, the model is learn from its limitation. Means the model highly learned from the data, but it can also cause some error in the examination process. So this is known as overfitting. Models learn some extra things which we don't need. Okay. So now, evaluation metrics for predictive models. After the all examinations, we need to compare which will be the better. So that's why we have some metrics or some calculation process. to predict that which algorithm is best for the same problem. Means we have a problem and we have multiple choices. So out of these choices, which will be best? So that's why we need evaluation metrics. So we have mean absolute error, mean squared error to quantify the prediction error, r squared, then root mean square. Okay, so cross validation helps to assess the model's performance on unseen data. Overfitting occurs when a model performs well on the training data but poorly on the new data. Underfitting is the opposite process, means it happens when a model fails to capture the patterns in the data. Means they learn in the low process when training. Okay, they learn slowly, they neglect the important features. So selecting the right evaluation metric ensures the better predictive accuracy. Model tuning improves the prediction quality. So now, cluster analysis. Cluster analysis is an unsupervised learning technique used to group the similar data points. Unlike classification, clustering does not require predefined labels. It is used in customer segmentation, anomaly detection, and pattern recognition. Means we don't have the last column. Means the labels. We just have the parameters, means the columns, the data points, and then we need to group it from our own side. Okay. So various types of is there, means k-means, dbscan are popular clustering algorithms. Partitioning methods divide the data into distinct clusters based on distance metric. Hierarchical clustering builds a tree structure to group the data points. So we will solve some numerical question, and I will also add some numerical questions videos in our video playlist of data warehouse and data mining. So clustering helps to uncover the hidden pattern in the large datasets. It is widely used in medical research, image analysis, and network security. So now, transactional and temporal patterns. Transactional pattern mining identifies the frequently occurring patterns in the transactional databases. It is useful in the market basket analysis and fraud detection. Algorithms like the a priori and EGLAT help to discover the association rules in the transactional data. Temporal pattern mining focuses on time-independent data relationship. It identifies the patterns that repeat over time, such as seasonal trend. It is applied in the stock market analysis, web users mining, healthcare diagnosis. Temporal patterns enhance the forecasting and strategic planning. Understanding these patterns improve the data-driven decision making. So that concludes our discussion on classification and prediction in the data warehousing. We will solve some numerical question, or from our side we will add some videos for numerical perspective or for Makaut examination for this subject. We explored the classification technique like the decision tree, naive bias, and SVM, as well as regression methods for prediction. We also covered the clustering technique and transactional pattern mining. These technologies are crucial for extracting the meaningful insights from the large datasets. In our next video, we will dive into the mining time series data, an essential topic for analyzing the trends and forecasting. So if you enjoyed this video, please like, share, and subscribe to Makaut Smasher. Stay updated and stay tuned for more exciting content on data mining and analytics. See you in the next video.